Hello and welcome to the turning movement study for Group 4 of Transportation Engineering Section 2. I am Thomas Jones. We have Tucker Carlisle, Gabe Peck, and Jaden Prasad. Understanding vehicular movements at intersections is crucial for optimizing traffic flow and ensuring safety of road users. As the demand for efficient and safe transportation systems continue to grow, the ability to analyze and optimize turning movements become increasingly more vital. The primary focus of this lab is to understand intersection behavior, more particularly the turning movement. The data was collected at the main entrance of Marietta's Kennesaw State University. Here is our effort statement. We worked all evenly on drafting, presenting the data, and report. As I said before, here is our location, which is the main entrance of Kennesaw State University in Marietta off of South Marietta Parkway.
We had two perspectives set up. The first one was on the northbound side of the Technology Parkway Southeast, and the second perspective was set up on the westbound side of South Marietta Parkway Southeast. And the study conducted counted all traffic that passed through the intersection. And these are some of our tables that shows our results. The first one is our totals for each bound, and that is organized into the left, through, and right. We use these totals to calculate the peak hour factors by taking the total and dividing it by the peak 5 minutes and multiplying that by 12. And then we also have our heavy vehicle count for each bound.
So this is going to be a graphical representation of some of those findings. It is counting the total number of cars that turned onto each section of the highway. For discussion, there are certain errors or certain sources of potential error. One of those is the way that we collected data. In the video, there was times when traffic was actually blocking the camera, like large vehicles, and it was unclear whether cars were turning or not. And then we also could have miscounted or missed cars. And then to obtain a more accurate data set, we would have to observe traffic over a period of multiple hours and then stretch that over a span of a couple of days to get a complete view of the turning data at this intersection. And then kind of a brief summary of some of our results. The peak hour factor for northbound turning lanes has more variable traffic flow and may be more receptive to spikes. The two left turning lanes compared to one right lane going westbound has a better consistent traffic flow, and the turning lanes south and eastbound both have a low volume of vehicles.
Based on the data at this time, the only recommendation that we can make is to extend the travel timing on the westbound left turning lane to be more consistent traffic flow. So what we concluded was the traffic flow in the westbound direction experienced the highest volume of traffic from the overall results, even though there is less traffic headed eastbound. It is a better peak hour factor, meaning it's more consistent throughout that hour. The turning lanes for most directions have a peak hour factor of less than 0.5. This causes the traffic flow to vary and be prone to spikes. And here's our references.
Thank you.
Thank you.
Thank you.
Thank you.